In this video, we will be learning about division properties of exponents. First, let's take a look at what a division property of exponents might look like. So we have here 3 squared divided by 3 to the third. If we expand that, we have 3 times 3 over 3 times 3 times 3. Now, to simplify that back into exponential form with one base and one power, we know that anything over itself is 1. So 3 over 3, that's going to equal 1. 3 over 3 is also going to equal 1, and what's left is 1/3 in the denominator for our final answer of 1 over 3, or 1/3. For our second example, we have y to the third, which is y times y times y, all divided by y. Y over y, anything over itself is going to be 1, leaving us with y times y in the numerator, which is y squared. How can I look at my original expression and, skipping this expanded form, jump straight to the exponential form? Keeping in mind that y has an exponent of 1, you might have noticed that I can simply subtract the powers to get my power in the simplified version. 3 minus 1 is 2. In this first example, 2 minus 3 is -1, which is why we end up with a 3 on the bottom, because 3 to the negative first power is equal to 1 over 3 to the positive first power. That brings us to our quotient of powers rule. For every non-zero number a and integers m and n, a to the m divided by a to the n is equal to a to the m minus n. This is basically the inverse property of our original that we learned. A to the m times a to the n is a to the m plus n. So when multiplying, you add the powers. When dividing, you subtract them because they're canceling each other out. One on top with one on the bottom. So the difference between them is whatever is left. And with the product, you're multiplying or you're combining them together. You're, for lack of a better term, adding them on to each other, adding on more a to the n's, adding on to what we already have. So let's take a look at some examples. For our first example, we have a to the 6th over a to the 14th. We'll talk about the 12 and the 3 in a moment, but a to the 6th, 6 minus 14 is -8. So if you notice, there's 6 a's on top, 14 a's on the bottom, so it makes sense that it's a -8 because the 8 that are remaining, when I cancel them out, will be on the bottom. And then this 12 over 3, we can just simplify that as a regular 4. So you can write it as 4 times a to the -8th, or 4 over a to the 8th. For our second example, we have c to the -1st divided by c to the 5th c to the -1st times d to the 3rd all over c to the 5th times d to the -4th. You could start by getting rid of the negative exponents first, or you can use the division rule first and then see if there's any negatives remaining. I'll show both ways. So first, if I just use the division rule, c to the -1 minus 5 times d to the 3 minus a -4, this will give us c to the -6th times d to the 7th, which would give us d to the 7th over c to the 6th as our final answer. If you wanted to get rid of the negatives first, you could simply by bringing the d to the 4th to the top and bringing the c to the -1st to the bottom, and that would look like this: d to the 3rd times d to the 4th, and then c to the 5th times c to the 1st, which would give us the same exact answer of d to the 7th over c to the 6th. So either method or strategy is going to work for you there. All right, our final rule is to divide, have a quotient to a power. So we have 2 over x to the third, that whole quantity to the 4th power. So this is going to be 2 over x times x times x 4 times. 2 over x times x times x, 2 over x times x times x, and 2 over x times x times x. All the way across the top we have 16, and on the bottom we have 12 x's with a final answer of 16 over x to the 12th. For our second example, we have x to the 4th over y squared, so twice. On the top, we have 8 x's across the top and 2 y's across the bottom. If you recall from our product of powers rule, the idea here is that everything, even in the quotient, gets raised to the power of 4, even the denominator. So 2 to the 4th power is 16, and x to the 3rd to the 4th, 3 times 4 is 12, but since the 3 was in the denominator, it stays in the denominator for x to the 12th. X to the 4th squared is 8, x to the 8th, and y squared is y squared. But again, since the y was in the denominator, it stays in the denominator. Just as a quick reminder why, if I brought the y to the top, it would be y to the negative first, and then when I would square it, I would end up with y to the negative second, which would make me take it back down to the bottom. So we just can save ourselves a little step there. Let's take a look at the rule, raising a quotient to a power. So any non-zero number a, integer n, a to over b to the n is equal to a to the n over b to the n. Let's take a look at some additional examples. Here we have 3 squared over x to the negative 3rd squared. So we would do 3 squared squared, which would be 3 to the 4th, or 9 squared, over x to the negative 3rd squared, which would be x to the negative 6th. Now, since it was already in the bottom, but it was a negative, up to you whether you want to move it up first and make it positive first, or save that step for the end. But our final answer would be 81 times x to the 6th power, because I need to move that up to make it a positive 6. For this example, we have negative 2 times x over y all to the negative 4th power. This is going to be two to the negative 4th power times x to the negative 4th power all over y to the negative 4th power. Now with this negative sign here, when we're doing something 4 times, since that's an even number, it's going to end up as positive. So we can eliminate that negative sign. Now we have all negative exponents because everything was raised to a negative power. So we need to basically flip the entire fraction to its reciprocal. So y to the 4th comes to the top, 2 to the 4th, which is 16, goes to the bottom, and x to the 4th goes to the bottom as well, for our final answer of y to the 4th over 16x to the 4th. Now let me just show you a brief shortcut with a problem like that last one. If we have a negative power, rather than raising everything to a negative power and then flipping everything at the end, you could start by flipping the reciprocal of the quotient inside and then raising everything to the positive end power. It is maybe slight shortcut at the end. It gets rid of the negative powers. If you rather save the negative powers to the end, that's also fine too, but I'll show you how this would work both ways. So 2 times ab to the 6th over a to the 3rd times b, all of that to the negative 2nd power. So one option is to raise everything to the negative 2nd power. So 2 to the negative 2nd power, a to the negative 2nd power, b to the 6th to the negative 2nd power, a to the third to the negative second power and b to the negative second power. When you do it that way, you have all negative powers. The other option is to take the fraction, the denominator, move it to the top, flip-flop that fraction to its reciprocal, and then take the exponent and make it a positive 2. When you do it that way, you should not have any negative exponents to worry about, unless, of course, there were already negative exponents in this quotient in the middle. If you went this route of just leaving it as is, you can then combine anything that you have there. So 2 to the negative second power, I just left as is, and then I did a to the negative second minus negative 6, which gave me a to the positive 4th, and then I did b to the negative 12th minus a negative 2, which gave me b to the negative 10th. Then, as your final step, you would get rid of those negative exponents with a to the 4th over 2 squared, which is 4, times b to the 10th. Over here, you would simply do everything to the second power. And then use your division property rules, the basic one that we learned first at the beginning, to simplify. 6 minus 2 is 4. Those 4 would be left on top. And then 2 minus 12 is negative 10, which would leave the 10 on the bottom. And then this, of course, stays on the bottom. So you would end up with the same answer either way you do it. It's kind of a personal preference which method you prefer. The main idea is that you would take your time, making sure you follow the proper rules as you go along.